So now, today I'm going to explain Faraday's laws. Faraday's laws. Faraday's laws. Now, so yesterday I explained Faraday's laws once again. So Faraday's first law. Faraday first law. So whenever magnetic flux linked with a coil changes with respect to time, then induced EMF, induced current set up in a coil is called as Faraday's first law. Faraday's first law. So next, Lenz's law. Lenz's law. So what is the meaning of Lenz's law? The first point, it gives direction of induced current and induced EMF. Induced EMF. Next, it is based on law of conservation of energy. Law of conservation of energy. Law of conservation of energy. Next, it converts mechanical energy to electrical energy. Mechanical energy to electrical energy. Lenz's law converts mechanical energy to electrical energy. It gives a direction of induced current, induced EMF. It is based on law of conservation of energy. It converts mechanical energy to electrical energy. Next, I'm going to define Lenz's law. Lenz's law opposes Lenz's law. Lenz's law is opposes. Direction of induced current, induced EMF is opposes cause which produced in it. Direction of induced EMF is opposes cause which produce in it. That is Lenz's law definition. Lenz's law, it gives direction of induced current, induced EMF. It is based on law of conservation of energy. It converts mechanical energy to electrical energy. Lenz's law definition is direction of induced EMF is opposes cause which produce in it. That is Lenz's law. Why I'm going to explain the Lenz's law here now? You see that. Now, do you know some basic points? The basic point is this is a rings. This ring carries current in a anti-clockwise direction. Front part acts as north pole, back part acts as a south pole. This is a ring carries current in a clockwise direction. Front part acts as south pole, back part acts as a north pole. That is a basic point. Now, second basic point is now this is a ring. This ring carries current in anti-clockwise direction. Front part act as north pole. Backside part act as a south pole. Backside part. Backside part. Now, direction of magnetic field is from direction of magnetic field is towards observer. Direction of magnetic field is towards the observer. Next, second basic point is this is a ring carries ring ring carries current in a clockwise direction. Front part act as a south pole. Back part act as a north pole. Direction of induced EMF is away from the observer. Away from the observer. This is a basic point. This is a basic point. Direction of magnetic field is towards observer. Direction of magnetic field is away from the observer. Away from the observer. Now, you see, this is a ring. So outside magnetic field travels from north to south outside, but inside is south to north. Inside is south to north. Now magnetic field lines are start from north to south outside. This is outside. Outside. This is outside. Inside is south to north. South to north. This is a very important. This is a direction of magnetic field lines. Now this is a direction. Inside, this is a magnetic field. Direction of magnetic field is this one. That's all. This is a field line is outside. Now we don't want outside, but we want inside. This is outside magnetic field. Don't want inside magnetic field lines. This is a basic point. Now I'm going to explain Faraday's first law. Faraday's first law. You see here, this is a copper coil. This is a bar magnetic. Now this is a north pole of the bar magnetic and the south pole of the bar magnetic. This is a coil. This is a coil. This is a bar magnet. Bar magnet. Magnetic. Magnetic. Right side voice is right. You see them here, north pole of the bar magnetic and south pole of the bar magnetic. This is a coil. Now, in this experiment, what I'm doing here, so finally, I want to induce current. Induce current. Here, this is a bar magnetic. This is a bar magnetic. This is a coil. Coil is rest. Bar magnetic is in motion. Motion. Magnet. This is a rest. This is motion. This is a rest. This is a motion. Bar magnetic is moving towards a coil. Bar magnetic is moving towards a coil. Means what happened? What will happen in this situation? Condition number one. Relative motion between coil and bar magnetic. Condition number two, changing flux. Maybe flux may be increased, maybe flux may be decreased, means there is a change in flux. So finally, induced EMF or induced current set up in a coil. That is now. So bar magnetic is at this place. Suppose bar magnetic at this place. Now bar magnetic is moving towards a coil. Bar magnetic is moving towards a coil. Bar magnetic is moving towards a coil. This is north pole of the bar magnetic, north pole of the bar magnetic. Now, in this bar magnetic is at this place, a few flux lines are linked with the coil, one or two lines. Now this bar magnetic very near to the here. So many flux lines linked with here. This bar magnetic is away from the coil. some flux lines linked with the coil. This is a field line, this is a field line. Two field lines are linked with the coil and a magnetic flux. Magnetic flux. Next here 10 flux lines are linked with the coil. Now here 40 flux lines linked with the coil. Now here 100 flux lines are linked with the coil. You see that one. You see carefully flux, change in flux. Flux is increases. Flux is increases. So this is a coil. This is a bar magnetic. North pole of the bar magnetic is moving towards a coil. North pole of the bar magnetic is moving towards a coil. So many flux lines are linked with the coil. Increasing flux lines linked with the coil. Then induced EMF or induced current set up in a coil. Set up in a coil. That is first. Now we are getting induced EMF. Induced EMF. Okay, ma, you see clearly. This is a coil. This is a bar magnetic. Bar magnetic is moving towards a coil, changing and increases flux lines linked with the coil. Induced current, induced EMF, induced current set up in the coil. Now, but what is the direction of induced current? What is the direction of induced current? Next, we want to discuss. But we are not seeing to the current. But so we are not seeing to the current. Now you see that one. This is a north pole of the bar magnetic and south pole. This is a coil. Now, north pole of the bar magnetic is moving towards this coil. Change in flux lines linked with the coil. Then induced EMF, induced current flows in the coil. But we are not seeing to the current. But galvanometer is connected between the two ends of the copper coil. This galvanometer shows the deflection. The pointer moves this direction. The pointer moves this direction means current flows in this direction. That is the direction of current. Direction of current. But suppose for example, okay, there is no galvanometer. We are finding the current in the galvanometer. Now, this is a bar magnetic. Bar magnetic is moving towards a coil. Current flows in this coil. This is a coil, bar magnetic, motion. This is a rest. Okay, now north pole of the bar magnetic is moving towards a coil. Increases flux linked with the coil, then induced EMF, induced current flows in a coil. But that induced current. What is the direction of induced current? What is direction of induced current? Induced current. What is the direction of induced current? Maybe induced current. Induced current maybe clockwise or anti-clockwise. Yeah. Induced current maybe anti-clockwise. Here, this is a coil, this is bar magnetic. North pole of the bar magnetic is moving towards a coil. Change in flux lines are linked with the coil, then induced EMF, induced current flows in a coil. But what is the direction of induced current? What is the direction of induced current? Induced current may be clockwise or anti-clockwise. By using Lenz law. By using Lenz law. What is the direction of induced current? Induced current may be clockwise or anti-clockwise. By using Lenz law. So Lenz law gives direction of induced EMF, induced current. Lenz law gives direction of induced current, induced EMF. How does it give direction of induced current, induced EMF. We have to check it. We have to check it. Now, with the help of the, so our target is, what is our target? Current in a wire, clock or anti-clock. We want to check. We want to check. We want to check induced current, induced current clockwise or anti-clockwise. Anti-clockwise. We want to check induced current in a coil, coil clockwise or anti-clockwise. By using Lenz law. Lenz. Okay. Lenz law. Now, it gives Lenz law. It gives direction of induced current or induced EMF. It is based on law of conservation of energy. It converts mechanical energy to electrical energy. Electrical energy. We want to check it. We want to check it. Now, let's find out. Here, so first of all, this coil is at rest. This bar magnetic is in motion. North pole of the bar magnetic is moving towards a coil. North pole of the bar magnetic is moving towards a coil. Increases flux lines linked with the coil. Linked with the coil. Then the induced EMF flows in a coil. Suppose I am assuming. Suppose I am thinking current in induced current in a coil anti-clockwise direction. I'm thinking induced current in a coil anti-clockwise direction. Suppose, for example, induced current is anti-clockwise direction. Now you see the induced current anti-clockwise direction means, so what is the direction of magnetic field direction? This is the direction of magnetic field. For this one, direction of magnetic field is this direction. Both are in opposite direction. Now you will see the both are in opposite direction. Suppose what I'm doing here clearly. Once again, I'm going to explain. This is a north pole of bar magnetic, south pole. Now, this is a coil. Coil is rest. Bar magnetic is in motion. Which direction? This direction. Direction of magnetic field is outside is. For this one, bar magnetic. This is a north pole and south pole. Direction of magnetic field is this is a direction. Outside. Direction of magnetic field is this side. Direction of magnetic field is this direction. Now, so north pole of the bar magnetic is moving towards this direction. North pole of the bar magnetic is moving towards this direction. Change in magnetic flux lines linked with the coil, then induced EMF, induced current set up in the coil. Maybe induced current, I'm thinking anti-clockwise direction, for example. Anti-clockwise direction. Anti-clockwise direction means the ring carries current in anti-clockwise direction, means that ring acts as a small bar magnetic. That ring acts as small bar magnetic. Front ring acts as north pole. Back ring acts as south pole. Direction of induced EMF, direction of magnetic field is south to north inside the bar magnetic. That is the direction of magnetic field. This is a bar magnetic direction of magnetic field. Outside is this direction. This is a bar magnetic north pole and south pole. This is the direction of magnetic field outside. Direction of magnetic field outside is this direction. But ring is inside. Inside direction of magnetic field is this direction. Both are in opposite direction. Both are in opposite direction. So what will happen? The bar magnetic is moving towards this direction. Again, it will be repel each other. Repel each other. And according to Lenz's law. Suppose for example, in case second case, I'm thinking suppose this is a north pole and south pole. Suppose current may be here. Current is anti-clockwise direction current, but here in this situation, current may be clockwise direction. Induced current. Induced current is clockwise. Induced current is anti-clockwise direction. Here I am taking now clockwise direction. Ring carries current in a clockwise direction. Now front part. This is a front part. This is a direction of magnetic field is this direction outside. Front ring acts as south pole, out ring acts as north pole. Direction of magnetic field is away from the observer. Away from the observer. You see carefully in this situation. Case number 1, I'm going to explain case number 1, case number 2. Case number 2, I may explain. You see in this, first we have to discuss this one. You will get the clarity here. Okay, now this is a coil, this is a bar magnet, north pole of the bar. North pole of the bar magnet is moving towards a coil. What will happen? North pole of the bar magnet is moving towards a coil, increases flux lines linked with the coil, then induced EMF, induced current set up in a coil. Maybe current, induced current may be clockwise direction. I'm thinking clockwise direction. Okay, clockwise direction. This ring acts as first, north pole of the bar magnet is moving towards a coil, changing flux lines linked with the coil, then induced EMF, induced current flows in a coil. But I'm thinking direction of current is clockwise direction. This ring carries current means the ring acts as a small bar magnet. Front ring acts as south pole, back ring acts as a north pole. Direction of magnetic field is from south to north. Direction of magnetic field is away from the observer. Direction of magnetic field of the bar magnet is north pole, south pole. Direction of magnetic field is this one. You see, both are in opposite direction. Both are same direction. Now, north pole of the bar magnet is right now. Suppose, for example, very near to the here, very near to the ring. What will happen in this situation? South pole of the ring and north pole of the bar magnet both are attract each other. Now this is a ring, this is a bar magnet, North pole of the bar magnet is moving towards a coil. North pole of the bar magnet is moving towards a coil. Changing flux lines linked with the coil. Induced EMF, induced current set up in the coil. Maybe current. I'm thinking current in a coil is clockwise direction. The ring acts as a small bar magnet. Front ring as a south pole. Back ring acts as a north pole. North pole of the bar magnet is very near to the coil, and this front ring acts as a south pole. North pole, south pole both are attract each other. In this situation, what will happen? Induced EMF 0. Why means so this is a coil, this is a bar magnet. Bar magnet is very near to the ring. Ring acts as a south. This is a back. Front part acts as a south pole. Ring acts as front part south. This is a north pole of the bar magnet is very near to the ring. Ring front part acts as a south. and this is Barmatic is very near to the and coil. Both are unlike poles. Both are attract each other. Attract each other. Now position of the Barmatic is attached to the ring. Attached to the ring. Now induced current is zero. Induced EMF. Induced current is zero. Induced current is zero. Induced current is zero. Now you take the situation number Lenz law. Lenz law gives it direction of induced current and Lenz law gives direction of induced current, induced EMF. It is based on law of conservation, which converts mechanical energy to electrical energy. But where is it? Electrical energy? Electrical energy is zero. Electrical energy zero. Law is Lenz law is failed here. Lenz law is failed. Here, Lenz law is failed in this situation. So Lenz law converts mechanical energy to electrical energy. Situation, law of conservation of energy is failed. Now you will see the suppose for example this is a ring, this is a Barmatic, now this is a ground. This is a ground. I'm giving the one stand. This is an insulating stand. Now this is a North Pole and South Pole. From here to here is some height. Okay, this Barmatic having potential energy. Potential energy, that is a mgh. Potential energy. Now Barmatic in the motion means Barmatic in the motion. This is a rest. This is a motion. I'm going to explain the. It converts mechanical energy to electrical energy. Electrical energy. Here, it is based on law of conservation of energy. In this situation, law of conservation of energy is failed. Law of conservation of energy is failed. Law of conservation of energy failed means it does not convert mechanical energy to electrical energy. Electrical energy zero. Electrical energy zero. In this situation, case number 2, coil, Barmatic. Barmatic is moving towards a coil. Barmatic is moving towards a coil. Induce change in flux lines, increasing change in flux lines linked with the coil. Then induced EMF, induced current flows in a coil. I'm thinking current in a clockwise direction. The ring acts as a small Barmatic. Ring front part acts as a south pole, back part acts as a north pole. Very near to the north pole of the Barmatic and the south pole of the ring, both are attract each other. Now, then finally, induced current is zero. Why means? And the coil attached to the coil. Why means north pole of the Barmatic front ring acts as a south pole. South pole of the ring and north pole of the Barmatic both are attract each other means both are in the rest. Both are in the rest means induced current is equal to zero. Induced current is equal to zero. Here Lenz law of conservation of energy failed. Law of conservation of energy failed. It does not convert to mechanical energy to electrical energy. Electrical energy. You see that one. Here, motion and potential energy. The motion means having kinetic energy. Kinetic energy. In this situation, very near North Pole and South Pole. Next, I'm thinking this is a clockwise direction current. Front part act as a, what is the act as? South Pole, back part is North Pole. This South Pole and North Pole both are attract each other. Kinetic energy is equal to zero. Kinetic energy is equal to zero, but potential energy having. You see the situation. Mechanical energy is equal to electrical energy. Mechanical energy here, kinetic energy zero of m squared plus mgh is equal to electrical energy. Here mechanical energy, kinetic energy zero, electrical energy also zero. Here in this case, electrical energy is equal to zero. And induced current is equal to zero. Electrical energy zero. Mechanical energy which converts to electrical energy. Kinetic energy also, you remove the potential energy. Don't want potential energy. Next, kinetic energy. The Barmatic in the motion. Barmatic in the motion means having kinetic energy. But in this situation, Coil, this is bar magnetic. Both are attaching. Both are in the rest position. Both are rest position means kinetic energy zero, and mechanical energy means kinetic energy plus potential energy. Kinetic energy zero. Kinetic energy means electrical energy also zero. Induced current also zero. In this situation, we are assuming current is anticlockwise is wrong. We are assuming current in a coil is wrong situation. But which one is correct? You see that. In the case number one, you see that. Case number one, you see, ma, I'm thinking, I'm thinking anti-clockwise direction. This is anti-clockwise direction. Current is anti-clockwise direction. Now, front part acts as a north pole, back part acts as a south pole. Direction of induced EMF is direction of magnetic field is outward direction. This is okay. Direction of magnetic field is limited. Bar magnetic is very near to the coil. This is anti-clockwise direction. This front part acts as north pole, back part acts as a south. And bar magnetic is very near to the coil. Not both are repel each other. Both are repel each other. Suppose I'm taking north pole of the bar magnetic is moving towards this direction. North pole of the bar magnetic is moving towards this coil. Change it and increases flux lines linked with the coil. Induced EMF, induced current set up in the coil. Then ring carries current in a anti-clockwise direction. We are thinking that is current or wrong. We are checking. The ring carries current in anti-clockwise direction. Ring carries current means that produces magnetic field. That produces a small. The ring acts as a small bar magnet. The ring carries current in anti-clockwise direction means that ring acts as a small bar magnet. Front part acts as a north pole, back part acts as a south pole. Direction of magnetic field is towards observer. Then finally, front part acts as north pole, back part acts as a south pole. Now this is a north pole of the ring. This is a north pole of the bar magnetic. Both are repulsion each other. Now you see, north pole of the bar magnetic is moving towards this side. The ring repelled to the ring push the bar magnetic is backward direction. Now the coil is in the motion. First bar magnetic is moving towards this direction. Immediately increases flux lines linked with the coil. Then induced EMF, induced current flows in a coil. Direction of induced current in a anti-clockwise direction. The ring produces magnetic field lines. Front ring acts as a north pole, back ring acts as a south pole. North pole of the bar magnetic, front part acts as a north pole. Both are repel each other. The bar magnetic is moving towards this direction. The ring pushes the bar magnetic backside, and north pole of the bar magnetic is moving towards this direction by using some north pole of the bar magnetic is moving by the ourself, and ring push the bar magnetic backward direction. Myself, bar magnetic is moving towards this direction. Ring push the bar magnetic backward direction. Myself, bar magnetic is moving towards this direction. Ring itself, ring push the bar magnetic backward direction. That is law of conservation of energies. You see what will happen in this situation. In the first case, this is a first case. This is a north pole of the coil and south pole moving towards the coil. This ring acts as north pole of the bar magnetic is moving towards the coil. North pole of the bar magnetic is moving towards the coil. Changing flux lines linked with the coil. Then induced current flows in a coil. That direction is anti-clockwise direction. I'm thinking anti-clockwise direction. Front ring acts as a north pole. Back ring acts as a south pole. This north pole, both are repel each other. Repel each other means again this bar magnetic is moving backward direction. North pole of the bar magnetic is moving towards the coil by myself, and ring push the bar magnetic backward direction. In the coil is in the motion. You see kinetic energy converted into electrical energy. So law of it converts mechanical energy to electrical energy. Now bar magnetic is moving towards this direction, and the coil pushes the bar magnetic is backward direction. Now finally Barmatic is moving towards this direction. Coil push the Barmatic back direction. Coil is in the motion. Coil having the kinetic energy that converts electrical energy. Now current is anti-clockwise direction is right. Current is anti-clockwise direction is right. Why means in the first case in the first case current is anti-clockwise direction is right. Why means uh, Lenzler gives direction of induced current, induced EMF in this induced current in this ring is anti-clockwise direction. Anti-clockwise direction. Why means it is based on law of conservation of energy. Law of conservation of energy is valid. This is a law of conservation of energy is valid. It converts mechanical energy to electrical energy. It converts mechanical energy to electrical energy. The coil moving towards the coil, the north pole of the barmatic is moving the coil. The coil push the barmatic is backward direction. And mechanical energy converts to electrical energy. Electrical energy. In the first case is law of conservation of energy is valid, and mechanical energy is converted to electrical energy in the first case. Now, finally, our conclusion is in the ring, north pole of the barmatic is moving towards the coil means and anti-clockwise direction and the induced EMF produced in a direction of induced current in a coil is anti-clockwise direction. Anti-clockwise direction. In the second situation, current is current is clockwise direction is wrong. Why wrong means it is a fail in the law of conservation of energy. It is a failed which converts mechanical energy to electrical energy. Which failed mechanical energy to electrical energy. Finally, our conclusion is our conclusion. What is our conclusion? Now, our conclusion, Ima. This is a coil barmatic, North Pole. So it's moving towards. Observer is standing here, and here anti-clockwise direction is current flows. Current is anti-clockwise direction. Anti-clockwise direction. Front ring acts as a North Pole, back ring as a South Pole. South Pole. Front ring acts as a North Pole. This is a front ring, back ring, Front ring acts as a North Pole, back ring acts as a South Pole. Next, another situation, North Pole and South Pole, moving away from it. Now, this is a front ring act as a front South Pole, back ring act as a South Pole. Now, current, suppose observer is here means this is now current is clockwise direction. Sorry, clockwise direction. This is now second situation. This is a second situation. South pole of the barmatic is moving towards a coil. South pole of the barmatic is moving towards a coil. Observer is standing in front of the coil. South pole of the barmatic is moving towards a coil. Front ring act as south pole, back ring act as north pole. Now observer is standing front means clockwise direction. Current flows in a clockwise direction. Clockwise direction. Now next, this is a ring. This is a south pole, north pole of the south pole of the barmatic is moving away from the coil. South pole of barmatic is moving away from the coil. Front ring act as north pole, back ring act as south pole. Current is anti-clockwise direction. Anti-clockwise direction. Now you see clearly. Now in this situation, suppose for example, in this situation. Now second situation. This is a north pole of the barometric. North pole of the barometric. North pole of the barometric. South pole. Now it is moving this direction. Observer is standing. Observer is standing back. Now front ring act as north pole but south pole. But current is in this direction. Current in this current is anti-clockwise direction. Anti-clockwise direction. Your current is clockwise direction. But the current is here. In the back, observer is here. Observer is here. Observer here means anti-clockwise direction. Observer here means clockwise. Observer is back side of the coil. The current is now south pole. Is seeing to the south pole. South pole means current is clockwise direction. Clockwise direction. Clockwise direction. Clockwise means this is a current direction. Don't confuse. Don't confuse. It is very very important. Now this is a one more. Observer is standing backside of the coil. Now north pole and south pole of the barometric is moving away from the coil. Now front part of the coil act as south pole. Backside is act as north pole. Now current is anti-clockwise direction. Anti-clockwise direction. Anti-clockwise direction. Now anti-clockwise direction means this is your current. Now you'll see in this situation, observer is standing here. Now I'm taking observer is this is a south pole of the barometric is moving towards a coil. Observer is standing backside, but your current is a south pole. South pole means clockwise direction, but your current is in this situation anti-clockwise direction. Anti-clockwise direction. Observer is standing backside, south pole of the coil. This is a south pole. This is a north. Sorry. This is south pole. This is a north pole, and the current is anti-clockwise direction. Anti-clockwise direction. Now, observer is standing here, and the south pole of the barometric is moving away from the coil, but the current. Observer is standing backside of the ring, and south pole of the barometric is moving away from it. Means this is act as north. This is act as south. Now you see current clockwise direction. Current is clockwise. Okay, once again you want to be check clock and anti-clock. Now north pole of the barometric is moving. North pole of the barometric is moving towards this direction means this is act as north. This is act as south. North means observer is this side means this side north means anti-clockwise direction. This is right. Next. North pole of the barometric is moving away from means this is act as south. South means clock. Now, north pole of the barometric is moving towards this direction. Observer is standing back direction means clockwise direction. Clockwise direction. This is a clockwise direction. Anti-clock, clock, anti-clock. Now, north pole of the barometric is moving away from this means south and north. This is anti-clockwise direction. Now, south pole of the barometric is moving towards the direction means front part this is south pole. South pole means clock. Now south pole of the barometric is moving away from means this is a north, this is south. Observer is standing here anti-clockwise direction. South pole of the barometric is moving towards the direction means this is act as a south, this is a north. North means anti-clockwise direction. Anti-clockwise direction means this is a anti-clock. This is clock, this is a anti-clock. Now south pole of the barometric is away from means north, this is south. South means this is a anti-clock, this is a clock. Clock. This is now you can write clock means south pole means clockwise direction. Clockwise direction. That is very very important. Based on the observer. Observer is this side. Observer is this side. But observer is this side. Both are in opposite. Observer is standing here means anti-clockwise direction. Same figure, but observer is standing backside. Here anti-clockwise direction, here clockwise direction. Observer is this side. Observer is standing this side. Same figure drawn here. You see, but observer is standing here, but here clock means here anti-clockwise direction. Observer is standing this side. South pole of the barometric moving here clockwise, but observer is standing here. South pole of the magnetic is moving. South pole of the magnetic is moving towards this direction, but current is anti-clockwise direction. But here, both are in opposite direction. South pole of the magnetic is moving away from here, but observe here anti-clockwise direction. But the same figure, observe here, south pole of the magnetic is away from here, but act as clockwise direction. That's so basic. What is a basic point means? Basic point, basic point means south pole means current is clockwise direction. North pole means current means anti-clockwise direction. Anti-clockwise direction. Okay. Keep in your mind this is a north pole. North pole is moving towards direction means this is act as north. This is south. South pole of the magnetic is moving towards this direction. South pole of the magnetic act as this direction means front ring. Front ring act as north. South pole. This is act as south, and this is act as north. 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 Next, finally, north pole is moving away. North to south. South to north, moving away. Here north. North. That is a basic point. You see clearly that is very, very, very important. Keep in your mind. Keep in your mind. Now, basic point. South means the ring acts as a south. The ring acts as a south. But south means clockwise. Clockwise. The ring acts as north pole of the magnetic. North pole of the magnetic is moving towards the coil means that front ring. North pole of the magnetic is moving towards the coil means that front ring acts as a north pole. South pole of the magnetic is moving towards the coil means that front ring acts as a south pole. North pole of the magnetic is moving away from means that opposite pole is formed here. And the south pole of the magnetic is moving away means north pole of the magnetic is formed that place. That is a basic point. Now, this is a very, very, very important. Don't confuse. Don't confuse. Okay. Once again, you see the basic points. This is a ring. Ring carries current in a clockwise direction. That means south pole acting. This ring carries current in an anti-clockwise direction. Okay, act as a north pole, anti-clockwise. Now, north pole of the magnetic is moving towards a coil means that ring act as a front ring act as a north pole, back ring act as a south pole. South pole of the magnetic is moving towards a coil means front ring act as north pole of the magnetic is moving. North pole of the magnetic is moving away from the coil means front ring act as a south pole. Automatically back ring act as a north pole. South pole of the magnetic is moving away from it means front ring act as a north pole, backside ring act as a south pole. Now you see the situation. First situation, north pole of the magnetic is moving towards the coil. Front ring act as a north pole, back ring act as a south pole. Observer is scanning this side means this side. Observer is seeing to the front part of the ring. Front front of the ring means north pole. North pole means anti-clockwise direction. Next, north pole of the magnetic is north pole of the magnetic. North pole of the magnetic is moving away from the coil. Here, south pole. Front ring act as a south pole, back ring act as a north pole. But observer is in front of the coil. Observer is seeing to the south pole of the ring. South pole of the ring means current is clockwise. north pole of the barometric is moving towards a coil. Front ring act as a north pole, back ring act as a south pole. Now observer is standing backside of the ring. Observer is standing backside of the ring. Observer is seeing to the backside part of the ring is find out to south pole. South pole means clockwise direction. Now north pole of the barometric, north pole of the barometric is moving away from the coil. Coil front side act as a south pole. Coil ring, coil backside, coil, I mean ring backside of the ring act as a north pole. But the observer is standing backside of the ring. He is seeing to the north pole of the ring. North pole of the ring means the current is anti-clockwise direction. Barometric is moving towards a coil. Front ring act as a south pole. Backside of the ring act as a north pole. But observer is front of the ring. Observer is seeing to the south pole. South pole means clockwise direction. Now in this situation, south pole of the barometric is moving away from the coil. Ring front side act as a north pole. Ring backside of the ring act as a south pole. But observer is in front of the ring. Observer is seeing to the north pole. North pole means anti-clockwise direction. Now in this situation, south pole of the barometric is moving towards the coil. Front ring act as a south pole, back ring act as a north pole, but the observer is standing backside of the ring. Observer is seeing to the north pole. North pole means current is anti-clockwise direction. South pole of the barometric is moving away from the coil. Front ring act as a north pole, back ring act as a south pole. Now observer is standing backside of the ring. Observer is seeing to the south pole. South pole means clockwise direction. That is important, very very important. Keep in your mind these points. Okay. Now now you see that this is a coil. This is a north pole and south pole of the market, moving very fast. Now say EMF, current, induced current, induced current, induced current, induced current. Okay, your coil. So situation number 1, 2, 3. EMF charge also. Charge. Charge means Q. Induced EMF. Induced current means current. EMF means voltage or E. Now situation number 1, situation number 2, situation number 3. So barometric is moving very fast, very fast. And now E, I, Q. Very fast. Barometric. Bar magnet. Barometric. So barometric is moved very fast. First slow. Barometric is moving. Barometric is north pole of the barometric is moving very slowly, very slowly. It's slow, slow, fast. Barometric is moving slow. Slow means EMF helps or less, and this is north pole of the barometric is moving towards the coil. North pole of the barometric is moving towards the coil is very slow. EMF, induced EMF setup in a coil is less, and north pole of the barometric is moving very fast. Induced EMF is more. Next, north pole of the barometric is moving towards the coil is very slow. Current also less current, less current. And north pole of the barometric is moving very fast towards coil, and current also more current, more current. More current in the situation. You see that one. Very simple. E I Q less speed, less fast, slowly bar magnet, slow and fast. Slow means EMF also less EMF, and fast means more EMF, more EMF, more EMF. Then slowly, barometric is moving very slowly. Current also less current. Barometric is moving very fast, means more current we are getting, and charge. Barometric is moving towards the coil is very slow, but charge uh, does not change. I mean, does not change. No change. Same charge. First, barometric, north pole of the barometric is moving towards the coil. Very fast means same charge. Same charge. Keep in mind. This is very important. Okay. Then you see that one. Okay. So today class is over. Up to this class. Next, I'm going to explain next class tomorrow. Tomorrow I will explain to next class. Thank you very much.